Hi. That's Amit, for those of you who are not familiar with him. And that's me. I'm the author of the book Advanced Apex Programming, also Salesforce MVP. I'm the CTO at Full Circle Insights, which is a Salesforce ISV partner. And I also run searchtheforce.com, which is a Salesforce-specific custom search. All right, so let me start out. Usually when people do programs like this, they present things that they believe are extremely important, well worth your time, best practices, a good learning experience. And I just wanted to give you a heads up that this particular session may not qualify as any of those. I'm a big believer that one of the greatest challenges that we all face as developers is keeping up and figuring out what to learn. And I think it's very important that we learn strategically. In fact, I have two courses on Pluralsight. One of them is called Learning Technology in the Information Age. The other called Keeping Up with Technology, that are all about figuring out what you should learn, when you should learn it, how to prioritize your time, and so on. And I try to live according to those principles. But every now and then, curiosity gets the best of me, and I learn something that isn't terribly practical, isn't particularly useful, just because it's interesting or fascinating. So we're going to be talking about Apex connectors for Salesforce Connect, and that already is a very niche topic, one that most people never will use. Most people will never create an Apex connector. Part of the reason for that is just building an Apex data source is one thing. You can do that on a developer org, but actually deploying it into production, the current pricing last I heard is $4,000 a month. So it's something that really only larger enterprises are going to do, only when they have some critical external data that they wish to surface within Salesforce. So this is probably not the best use of your time. The only thing I can say is that there's some pretty interesting code coming up. So those of you who are Apex developers, and I'm guessing many of you are since this is Apex hours, I think you may find some of the code patterns interesting in terms of the way I approached it. So, and you might find some of the things that I did are pretty interesting. So this all started about a year ago when I read a blog post on Apex connectors or Apex data connectors. And I've been familiar with Salesforce Connect and external objects. Everybody who took the particular Trailhead badge on that knows what an external object is. But I didn't know what an Apex connector was. I did not know such a thing was possible. And that made me very curious. And I had some ideas of things that might be fun to do with it if it actually worked. So I started working on this, and it was a little bit like Alice in Wonderland, Alice going down the rabbit hole, because I spent way too much time working on this, more than I could ever possibly justify for something that I was never actually going to use on my job or so on. And I would tell myself, well, maybe someday this knowledge will be useful. Maybe I'll do a Dreamforce talk on it or something. But Dreamforce, they did not accept this particular talk. I have no idea why. And the work I did just sort of was interesting and got set aside for a while, hoping one day that I would find a good home for it. And that finally happened in, I think it was just March. I can't remember the exact dates, but London's Calling was interested in this. And I did a 20-minute presentation there on the subject of creating impossible reports using the custom Apex data connector. And here, for the record, is the YouTube channel where you can see this. And the reason I'm putting this up here is because I'm not going to repeat everything that's in there. I'm taking a somewhat different slant with this talk, where at London's Calling, my focus was sort of on the concepts and the reports themselves. I figure you can see that in the YouTube channel. And I'm going to focus today on the code, which I was not really able to do during the 20 minutes that I was on stage for London's Calling. So what is it? What is it that drove me to going down this rabbit hole? Well, first of all, for those who are not familiar with external objects or Salesforce Connect, maybe somebody didn't take that particular Trailhead badge, the idea is that you can take an object on an external system and you can make it appear inside of Salesforce as an external object. And if you can have that appear as an external object in Salesforce, you can do things with it. You can query on it, you can report on it, and basically it becomes an object that you can use in Salesforce as if it was a native object. And the way you connect, the way you do this and bring external objects into the platform is by using a data source. And most of the time, these data sources connect by way of a standard connector, such as OData or some other standard protocol, which sort of comes out of the box. And this is what I suspect 99% of everybody who does external objects would do. However, they also have the ability to use Apex. And what would happen here is Salesforce would call into your Apex code and say, hey, get me, I'm doing a query, so get me the external objects, or I'm doing an update or an insert or so on. And Apex is the go-between, and Apex would do the callouts to the external system. So that allows you to connect to external systems that don't support one of the out-of-the-box data source protocols. So the idea I had that drove me to waste ridiculous amounts of time on this project was, could I do this? Could I connect? And if somebody's raising their hand there, I don't know if you want to ask a question.
You can
Okay.
carry on then. We will take the Q&A session in the last.
Do the
Or if you
Q&A
have any
session.
question, feel free to post your question on the chat window, please.
Okay. So anyway, I had this idea that what I could do is I could call back into Salesforce. And the reason one might want to do this is because you can query in SQL, you can query objects that normally you can't report on. So for example, I could do a report just using standard Salesforce reporting of an Apex class and said, wow, that would be pretty cool to be able to get like a report of Apex classes and who modified them last and what API versions there are and so on. So you could say, okay, show me all the Apex classes that are on an older API version. Things like that. And there are all kinds of things that you could do. You don't even have to query an object. You could generate it programmatically computed data and have it reportable. So I thought this is just an incredibly cool thing if you could do this. And that's what drove me to spend all that time figuring out how to do this. So before I show you an example of that report and then we dig into the code, let me give you some warnings and caveats. So I know usually in a session like this, you would see real code, examples of good code, production ready code, and so on. The code I'm going to show you today is absolutely experimental. It is literally as I was exploring and playing around. This is not even remotely production ready code. It does not reflect best practices, though. As you see the changes I made from the example that is provided by Salesforce, I think you might find some examples of best practice designs in there, or things that I believe over time would become best practice design. There is no proper error handling. Part of the reason for that is, as far as I can tell, Apex connectors have no proper error handling. One thing, if you are going to experiment with this code and play around with it, if there are any problems at all in your Apex connector, it is virtually certain that things on the Salesforce side will not work, and that the error message they give you will be absolutely incomprehensible or unrelated to what is happening in the connector. So, unfortunately, this is not one of those cases where, if you make a mistake in the connector, it's going to come and say, hey, look, you made this mistake. No, it's going to just sort of show you no data or come up with some completely misleading error message, and you're just going to have to do trial and error to make that error message go away. So that's one thing to be aware of, and one of the reasons that the experimentation for this took such a very long amount of time. There are, of course, no guarantees. I'm sure there are bugs in here. I have not even thoroughly tested out the functionality that I implemented. It probably doesn't scale, and by that meaning that the implementation, the design should scale, but I never tested it at scale. So I'm pretty sure that if you actually tried to use large amounts of data, that there's still bugs in there. As I say, not even close to adequately tested. There are no unit tests. I was going to say this is a work in progress, but in fact, this is a work with no progress because I have no need for this. Therefore, at the moment, I have no plans to work more on it. So really, what you're seeing, what I'm going to show you is pretty much the way it was on the day that I said, okay, I've learned enough. I've proven the concept. This is really fascinating. I have other things to do. So this is absolutely a session that is about just exploring and having some fun with Apex with a particular platform feature. And I think in a way this is an important example because it is okay for any of us as developers as we're learning Salesforce to not have to become an expert on everything we learn. It is absolutely okay for us to pick something, learn it up to a point, get familiar with it, have some throwaway code, and then walk away with that knowledge. You can always come back to it later if we want. So let's go ahead and, well, I'm going to put up one more slide because that way we may not have to come back to slides until the very end. This is here. So on the playback, you can see it. This is where you can get the code. It's up on GitHub, github.dan-appleman. You can find it, London's Calling and Possible Reports. I haven't changed anything since London's Calling, so the code is the same. So let's go ahead and let me show you first an impossible report. So this is an example of that Apex report that I told you here. This is a Scratch org. There are all of 2 classes in it, and you can see the API version, the size, and who modified it last. Some of the other reports, let me close that, start it, that I implemented that I'm not going to show you right now. If we go to other reports, group member assignments is sort of cool. You can say which users are assigned to which groups. Permission set assignments. You can say who's assigned, what are your permission sets and who are they assigned to, and profiles. So for example, you can do a report on all the profiles in the system and figure out, say, which ones are modify all data, which ones have certain permissions. One thing that we were discussing at London's Calling that might be a fun extension would be to get the profile permissions by user, and that would be sort of a really cool thing to do a report on. So you could say, okay, give me a report and show me just like that in standard Salesforce reports which users have modify all data permissions. So those are some of the kinds of reports that you can do with this technology. All right, so let's see. I'm going to start out and show you what one of these things look like. And this particular example here is the loopback example that's provided by Salesforce. Now, right now, this works, and it works with reporting. Back when a year ago when I started working on it, the reporting side was very buggy. So this didn't actually work properly, and I had to spend a lot of time figuring out what were the quirks to make it work. But now it works. They've definitely improved things. Every data source begins with a provider that extends the data source.provider class, and it implements 2 methods. The first one is get authentication capabilities, and this one tells you how this data source can authenticate into the external system. So from our purpose, we're just doing anonymous and basic. This will for the loop back, this will be just fine. We're not using, you don't need to use OAuth or so on, because this data source is already authenticated. I mean, it's running Apex, so there is no authentication really needed to get into your own system. And then here's where you specify the capabilities. Right now, the example has only query and search, but you can implement insert and delete and so on. Again, for my purposes, I had no interest in going into that direction because I was all about querying information on my existing org, not updating it. You know, you're not going to update Apex classes through a SOQL query. I mean, that wouldn't work. So, I mean, I suppose in theory, one might be able to figure out a way to do it, but I don't even want to think about it. So that's the provider. One thing that's important to know is there's also the data source connection class. This is the one that does all the work. Anytime you edit one of them, you have to save both of them. So if you don't, things break. This is actually documented, and I do not know why that is, but it's something about the way these Apex data sources work, is that you can't just update one of these. You have to update both of them for Salesforce to recognize that that something's going on, that something has changed. Okay, the first method is the sync method. Now, what the sync method does, this is pretty much gets called when you click on sync for the external object and you say, okay, basically update my external object based on the information that the data source is providing. So this is where the data source gets to provide information to Salesforce on the nature of the external object. The example provided by Salesforce is only going to map the account object. So it's literally reflecting part of the account object back as a new external object, and all it has is the name and the number of employees. So what you can see is we basically specify the columns, we add an external ID and display URL. External ID is required. I don't recall if a display URL is required or not, but I put it in there anyway. The name of the column, and then you basically add you know, the column. So we got name, number of employees, and no, excuse me, that's not the name of the column. That is the column name, a column that's name. That is the name of the object. And here is where you basically add it to the table. So the table is going to be called looper. Its name column is called name, and you specified the columns. So that's how the sync works. Query is what gets called. There are two main methods that are going to get called because, as you can see here, we specify query and search as the features we're supporting. So we have query and we have search. So a quick look at search. Search didn't really get implemented in any fancy way. What they're using basically a data source.searchutils. Searchutils and query utils are objects that are provided by Salesforce for development purposes, which means basically they're going to do all the work for you, but they're not designed for use in production environments. In the documentation, in one place it says they're not designed for use in production when callouts are used, and then another place it says they're not designed for use in production. So, but the search utils, it's a little bit unclear whether that's legitimate to use or not. But I didn't worry about it at all because I wasn't interested in search. I was only interested in query. So the query, they look pretty much the same on every data source that I've seen. First, you have special handling for count, where you're going to basically retrieve the number of rows that are out there. And I'll show you these methods in a minute. You call exec count, and you pass it a count query. And then you basically build up the result that gets returned to the to Salesforce. So, you know, basically you put the information in a row with the count, you add the count row, and then you basically return a table that has one row that contains the result of the count. Similar kind of thing, if it's not the count query, except we're doing an exec query. We're passing it the query string, and we're building a table that contains all of the rows that are resulting. The context is, think of that as a SQL query, all the information that a SQL query would get. So that's where you're going to have the filter or the where term and the order term and the sort term and the limit term. All of that stuff is in there, but it's not in a text string. It's in an object hierarchy that basically describes what it is that is being queried. And our job is to sort of untangle that and turn it into something that we can send to the external system that will perform those kinds of operations. So for example, if this query context says, I want all of the external objects whose names start with the letter A, you don't want to query the external system and get all objects and bring them in and then search through them and figure out which ones start with A. What you want to do is you want to build a query that the external object understands and only retrieve and have the system only send you those objects that begin with the letter A. So essentially we're translating the filtering terms of the SQL language into whatever language the external system needs, like SQL or I mean, I guess external systems would almost always be SQL, but that's the ideal. That's the way you want to do things. And that is the way it is done here, where we're taking this context, which is generated from the original SQL statement, and we're going to turn it back into SQL. So we're sort of going to do a round trip here. So how does that work? Let's start with exec count. Exec count returns a count, and it gets a SQL query. And what is the SQL query? It's going to get count query, and get count query looks like this, right? And everybody's seen that. So basically, what we're doing is exactly what I described. The context, we know that the context is a count query because that's what we did here. We said if the selected column size is 1, and if we're data aggregation query count and we're doing a count query, then we want the query to be select count from account. And there is the filtering that gets processed here because we may not want to count all records. We might want to count based on a filter. And if we have a filter, then we're going to add a where term to our count query string. We're going to do almost exactly the same thing for a regular query, exec query, except it's going to be a little bit more complicated. So let's see what the exec query looks like. Let's see, where is this? It's going to call get SQL query. So it's going to get a query, and it's going to query, it's going to get the query string, and then it's going to go ahead and once it gets the accounts and executes the query, then it's going to go, and for each of the rows that it retrieved, it's going to basically create those rows and basically set the values that were retrieved into a format that Salesforce Connect, that Salesforce can understand going through Salesforce Connect. So, we're basically recreating a query, we're executing that account query, and then we're taking all of the values that we retrieved and we're building up these new rows in the format for Salesforce Connect. So the get SQL query is where we actually get the query string, where we take our context, which has that data structure that was generated from SQL, and we're going to turn it back into a SQL query. And it starts with the select statement, where we have the fields and the object we're querying. And of course, it's hard-coded here to match ID, name, number of employees. Back when we synced, right? We had ID, name, number of employees. So we're basically, here we are. We're basically doing the same query, except it's all hard-coded here. And then we build the filter, and we're going to add the filter using a where term. So how do we build the filter? We use get SOQL filter, and it provides the initial query string, if there is one, and the filter statement. And what it does here, it's a little convoluted, but it starts out and says, okay, is this a compound filter? So one that has a not or an and or an or. And if it is, then, for example, if it's a not and there are subfilters, then it's going to go and call get SOQL filter on the subfilters, right? So then it'll become not and then whatever the term is after that. Otherwise, there's this get SOQL filter compound where you can basically build two sides of an and statement, or an or statement, or just a regular expression. So it's basically drilling down, and depending on whether it's an and, not, or compound statement, or if it's just a regular expression, it's going to build it. If it's a compound statement, then you're going to get the operator in between the two filter sides inside of parentheses. And if it's an expression, then it's just going to go through and say, is it an equals or a not equals or a less than or a greater than, and so on, or a like statement. And again, build, the column name, the operator, and then the value. So, it might be, field greater or equal than 5. And here would be your field, then greater or equal than 5. So it's basically going through this set of filters, and parsing them out and regenerating a SOQL string. There are a couple of small subtleties. For example, we have this map column name function that says, an external ID. If it sees a column name of external ID, we actually want the ID column, right? Because there is, in a standard account, there's no external ID object. External ID field, there's an ID field. So we'll just do it that way. And then this wrap value function basically puts values inside of quotes if it's a string, which is what SOQL expects. So a lot of work to basically take this context data structure. Where are we? Back in exec query, and right up here, this context data structure that has all of these SOQL components and turns it back into a SOQL query string. And one of the reasons that I'm sort of taking a close look at that is because you're going to see that along the way, I changed this. And I think in a way, the way I changed this is the most interesting part of this entire project, especially since, as we've spoken earlier, the project itself is probably not particularly useful for anyone. So this is what the original example looked like. And what I'm going to show you now is how I started from this point and turned it into what you saw earlier, which is this ability to do much more sophisticated reports. For example, if I do a group membership report, the group member assignment object doesn't have the group name. It does not have the username in the object itself. So I actually have to do I have to bring in related fields from other related objects in order to make this work. So it makes for a somewhat more sophisticated piece of code. So let's switch over to the impossible data code. Okay, so the provider is pretty much the same. The only difference is I didn't bother with search. I don't even know why I put row update in there, because I didn't do anything with it. I think I quickly figured out that that was a waste of time and commented it out. But I decided not to worry about search either, because the kinds of reports I wanted to generate, they were not the kind of thing you're going to search through from the main search window. It's really all about querying and reports. So the connector, let's start with the sync section. So it's more sophisticated, mostly because there are 4 tables here. So the first table is profile permissions. And as you can see, it has the name, user type, external ID. But then I have this loop here where I go through and I build a whole bunch of columns for different permissions. And I generate that dynamically. And the way that's generated is by going through and I get basically all the fields on the profile object. And then I go through each one, and if it starts with permissions, because there's this convention on the profile object that if it's a profile permission, it starts with the word permissions. So if it starts with the word permissions, then I just add it to the list. So as a result, I basically instantly create a whole bunch of columns. And in fact, this report has a column for every profile permission. And here is where things get a little tricky, which is that'll work fine, but if they add a permission to the profile object, that permission will not automatically get populated into the external object until you resync the external object. So there's no magic there that if they add a permission suddenly, oh, now it suddenly appears. You actually have to go through a resync process. And when you do the resync process, I'm pretty sure you have to go to the external object and once again re-enable reports for it, because I think it sometimes loses that when you do the resync. So that's the impossible profiles table. Yeah, I have a little more here. Unlike the loopback, I had a description and the singular and the plural, and that becomes the information that's used to create that external object when you do the sync. The Apex classes one is fairly straightforward. These are just fields on the Apex class object that I want to have appear in my report. And then I create another table. Now, this one gets a little bit trickier, which is on the permission set assignment, I have things like the name of the permission set name. That's not part of the permission set assignment object. That's part of the permission set object. So, and the same thing with the, well, not so much the assignee, but the name in particular. So I'm going to be going to a related object there, and not exactly reflecting just the permission set assignment object, but actually bringing in some of the related fields. And the same thing happens with group member assignments, where the group member assignment object, I think that's what it's called, the name isn't on that object, and the username isn't on that object. So I'm going to be going to related objects to get those. So those are my 4 tables. And I have this other step here where I set up the column labels. And what I do there is, again, a somewhat a significant extension over what the loopback object does, which is I go through the table and I'm going to look at the class name. I'm going to look at the fields and basically saying if it's a related field, I set the label of the column to the name of the column. But otherwise, I'm going to go ahead and I'm going to populate the column's label description, whether it's filterable or sortable, based on the described information for that field. So I'm adding some intelligence to the column information based on the described information for the field, which will help Salesforce to basically create those fields and say, okay, well, this is a sortable field, or use the correct label for the field instead of necessarily the API name. Okay, going back. Okay, now let's look at query, and we're just going to sort of work our way down through that code. It's very similar to what we saw earlier, the first part of it, where we do the count and we're going to do a count, get count query. I'm not going to look at that because that's almost identical. And this part is well, before I get to that, I'm going to show you a couple of utility functions that I use. Okay, first one is map column, not column name. Which one? Okay, first one is this one here, which maps the table. This is a map that maps the table name to the class that we're actually going to be querying, because we're going to be doing everything dynamically, right? But where before you saw the SQL query was hard-coded with the account, the fields in the account, we're going to be doing all of that dynamically based on what we set up. So the impossible profiles is going to query the profile class. Impossible classes is going to query the apex class object. Impossible permission set assignment is going to query the permission set assignment object, and impossible group members is going to be querying the group member object. So when we generate the SQL query, these are going to be the objects that we're going to be actually querying. So that this is the way we know that. The column names get mapped. This is an extension of get column name that you saw earlier. For example, if the column name is external ID, we're going to actually want to query the ID field. Same thing with display URL. For classes and profiles, the column name and the API name we're querying are going to be the same. But for permission set assignment and group members, we've got some trickier ones. For example, for permission set assignment, if it's the description, well, there is no description field on the permission set assignment object. So we actually have to go to permission set.description. And note, not only do we have to use that when we're getting the value of the description, we're going to have to do basically look at the row and do an sObject.get with permission set.description. I'll show you how we do that a little bit later. But we have to be sure that permission set.description is in the SQL query that we generate. Same thing for permission set.name. There is no name on the permission set assignment object, but we want that name to be in our derived external object. So we're going to do that related query. Same thing here for impossible group members. We're going to be getting that looks like a bug. It's probably not supposed to be permission set description here. That's sort of weird. Okay, well, for some reason it works. Maybe there is no description field, so this is just a copy paste error. Anyway, told you, experimental code. So anyway, but we get the group name, again, is the name on the related object. The type is on the related object, and member ID is going to be the user or group ID in the group member object. It has user group ID, but we're going to call it member ID. So this is just a mapping of what is the name in our external object versus what is going to be the name or field name in the object that we're querying through this data source. Similar thing for get column value. It's almost exactly the same thing, except the job here is not to retrieve the field name that we're using in the term we're using in the SQL query. This is what we're used to actually get the value. So for example, if it's external ID, we want to take the object that we got back and we want to do a get of the ID, not the external ID. And we also, since we're returning an object, we want to be sure we cast it to the correct object type. And this is a weird subtlety that at the time didn't work. I don't know if they fixed it, but if I was to return just return this as an object or as an ID type, it just wouldn't work. So ID, way up here, as you can see, external ID is defined as text. Whatever this is defined as up here, you have to return that type. You have to cast it to that type, or it just doesn't seem to work properly. So let's go back to where I was, map column names, get column value. So you'll notice that I cast everything here that needs to be a string gets cast to a string. So display URL, I actually go ahead and build out the URL string. For impossible classes, here again, if it's the creator is the name of our column, we're going to do an obj.get created by ID. Now, a little bit trickier is how do you deal with permission set.description, right? Or permission set.name or group.name. You can't just do a get with a compound term like this. It doesn't work. So we have this get field value method that basically looks through and says, okay, if the field name contains a period, if it doesn't contain a period, then just do an obj.get. If it does contain a period, split the different segments, and then we split it at the period, so we have each term, and then we're basically going to go through each segment, and for the first ones, up until the very last one, we're going to do a .get s object, which gets us the related object, and then at the very end, for the very last one, we're going to do a regular obj.get to get the field value. So this is our code that's able to take this related query, and as you can see, the code's designed to go to as many levels of related objects as necessary and retrieve the actual value so it can populate it into the table that's being returned. So these are a couple of utility functions that come into play back in our query. So we're going to get our rows, and then we're going to basically loop through the rows that we retrieved using database.query and go through each column, get the column value, and put it in the row. So we're parsing the data that was retrieved, retrieving the actual value, and putting it into the table that we're about to return. Another thing that we do here is, you notice we actually retrieve the total rows as well and shove it into the query result.total size. I spent a ridiculous number of hours before I finally I'm not even going to say I figured it out. I just tried this and suddenly things started working. So at the time, and I don't know if it's still true, but at the time, for the external object and regular queries to work, they would be fine without setting this total size here. But for some reason, Salesforce reporting really wanted to know that size. It couldn't figure out for itself how many rows you returned. You had to give it this. So that seemed to make it work. So that's why I do it here. Again, I don't know if that is still necessary. You can sort of see I still have all kinds of debugging statements planted in here to, as I was trying to figure out what was going on. Okay, on to the query itself. If we go through, we're going to be parsing out this get SOQL query, right? Because that's what translates this context into a new SOQL query. And I took a slightly different, I don't know if it's slightly, but a significantly different approach in that if we go through here, first of all, as you can see, there's no hard-coded query string to begin with. What we do is we go through the columns and we add the fields one at a time, map column name. So this is where we go ahead and we get the field, as we discussed earlier, that we're actually going to query for a particular column name. So that's where it does the mapping, and it builds the list of fields that we actually want to query, and it just adds them to the select string, joining them together using commas. So now we have our select string with all of our fields all generated dynamically. Then there's, of course, a from. Then here's the mapping from the table name to the Apex object that we're querying. So again, this is dynamic. If the context has an offset, then we add the offset term to the SOQL query. Then we have the get filter term, where we're going to get the where part of the query. There's also a get order term that's going to add an order by. It's like order by any fields that you're sorting. And then there's a limit, context.max results. So as you can see, we're not ignoring these other parts of the context as the loopback example did. We're including those. I don't know if any of these actually work, but the approach, I'm sure the approach is correct, but there might be bugs here still in this. So we're going to look at get SOQL term and get order sockle term. Let's look at get order sockle term first, because that's the easy one. Basically, it goes through and it says it's taking this order object, which is part of that context, and if it has one or more orders, then it's just going to go through and basically add an order by an ASC or descending, right? And you can have as many of these as you need. So it's going to build out that order by string, append them all together, and return the ordering term for the sockle statement. So we've reassembled that. Then back to get query. Okay, and then get filter sockle term. This is where I had a lot of fun working on this one. Instead of having those three different methods, get filter expression, get compound filter, and so on, there's just the one get filter sockle term, which is called recursively as needed. We have this filter map, which is a mapping of the various filter types to the sockle expression. And one thing you'll notice is that the like expression, instead of doing strange things, I actually built a formatted string so that we could do that in the same way as we're doing the other ones. So we start out and say, okay, if there are subfilters, then that's where we're going to be assembling the compound object. Then what we do is we say, okay, if there's just one, then there's going to be filter map.filter type, which will probably be like a not or something like that. And then we recursively call all the subfilters. So we call this again. Same thing, if there's more than one compound type, then we're going to put it in parentheses. And again, recursively call the first one. And then for each other subfilter, we're going to add the filter type and recursively call this. So this is where you might get field 1 equals A and, right? So parentheses, field 1 equals A. Then you'll have and field 2 equals B and field 2 equals 3. So it's going to sort of assemble that string here for each term, if necessary, recursively calling in and building out any subfilters. So it's all happening in one method. If there are no subfilters, then if it's got a merge, so it's going to be a like or similar kind of thing, then it's going to build that and use string.format to shove the like term, basically the column value into that like statement. So we're going to shove it in there. Otherwise, it's going to be a simple, column name, for example, name equals 5, right? Or whatever it is. So basically, it's sort of a really neat example of table-driven recursion that, in theory, and again, I haven't tested it out thoroughly, but in theory should very, very easily recreate the original sockle filter, and that's it. As I said earlier, it queries it in query. We get the rows, we shove the results into the rows, and we return it, and everything works, and it's just sort of like magic. So that's the walkthrough of the data source code, and I think it's pretty cool code in the sense that it shows you how to take that very hard-coded loopback example for one table and turn it into a very dynamic table-driven data source where you can add as many of these as you want. And if you're a large enterprise and you find value in these kinds of reports, and I think administrators would find great value in many of these reports, maybe a large enterprise could justify $4,000 a month. And one of the nice things about this is that it is $4,000 a month, but it's per data source. So you could build as many different external objects as you want into this single data source and basically get access to all of them for that $4,000 a month. And who knows, if you're a good negotiator, you might be able to bring it down from that. So that's at this point, I will open it up for any questions, and I will let Amit handle that, since I do not actually have access to the chat window while I'm sharing my screen, as far as I can tell.
Yeah, thank you, Dan. So let me check the chat window. Till now, I did not see any question. So guys, if you have any question, feel free to unmute yourself and ask a question directly with the Dan.
It could be I scared them all off at the beginning when I told them how useless this would be, right? Either that or everybody's in a state of shock.
Till now, no question. So then, like, this code is available on the Git repository, right?
Yes, it is. Let me go
So
ahead and
I will try to copy this and will upload into my Git repository, and will share with the Apex R1 with everyone, so that they can use the code and they can implement the same in their project.
well, as I say, this is a public Git repository, so anybody's welcome to fork it or clone it or whatever. And I'd certainly entertain if anybody has any suggestions on how to fix it. But I don't, as I say, expect to be spending any significant amount of time on this going forward. It's just a really fascinating, thing that one can do in Apex that I just had no idea was possible.
Got it. I see some comment. This is awesome discovery, and that's it. I don't see any question here then. So I hope we are good.
Yeah.
Yep.
All good. We got it. We got it under an hour, so it's an Apex hour.
Yeah. Right. So thank you everyone for the joining our session, and thank you so much for the great learning for us. And thank you everyone, and I will share this recording on our YouTube channel, so that if you want to go through this again, you can go through that one. And thank you everyone.
Thanks, Dan. Thanks, Amit.
Thanks all for joining.
Thanks, Dan. Thanks, Amit. Thanks for everyone.